All right, pre-calc, chapter 2, section 2, part 1 is going to be all about quadratic functions. So we're going to talk about how to graph quadratic functions, in particular when they are in standard form, and then that's pretty much it. So first part is, we know most of this stuff already, is going to be a parabola. When we talk about if the graph opens up or down, we know it's going to open up when a is greater than 0, or down when a is less than 0, which is actually what these next two are going to say. Okay, so we're going to have a value of a, and that's going to tell us if it opens up or down. So a is greater than 0, it's up; less than 0, it's down. If it opens up, then our vertex is our minimum, and likewise if it opens down, then our vertex is our maximum. And what I mean by all of that, if we talk about our standard form, it would look something like this. So this, our a value, if it's positive, we open up; if it's negative, we open down. And then we're going to have our vertex, which is going to come from the h and k values. So h, a lot of times we say hates its sign. Remember, it's going to be the opposite. So if it's -4, h is actually a +4. K is going to keep its sign. Okay, so h hates its sign, k keeps its sign. That will be your vertex. And then your axis of symmetry is going to be just x equals h. So if we look at a couple examples here, if we want the center for this one, it would be 2, 12, and that means our axis of symmetry is x equals 2, and we know, because this is negative, that it opens down. Okay, our next one, our center would be -1, +5. Remember, it hates the sign. Our axis of symmetry is going to be x equals -1, and this one also opens down. Okay, last one then, our center would be -4, -8, and our axis of symmetry is going to be x equals -4, and this one, all three of these examples, open down. And now, if we take that one step further and we graph it, what we're going to do first is determine if it opens up or down. Remember, that is based on the a value. Then you're going to determine the coordinates of the parabola, of the vertex of the parabola, which means we have h, k. So the first piece is your a value. Second piece, h and k are going to give you the parabola. If we then solve the equation f of x equals 0, this is going to give you your x-intercepts. Okay, in possibilities, you could have 2 of them, you could have 1 of them, or there could be none of them. Okay, the last piece, and what we're going to need to do for this is we can distribute in our quadratic formula, or we could do a square root property. Okay, so one thing here, square root property. Okay, and then we're going to do f of 0, so we just plug in 0 for your x and simplify. This is going to give you your y-intercept, and then you can also use this to get a point of symmetry. Okay, and I'll show you what that means in a minute. Our parabola is always going to be the same on both sides of our axis of symmetry. So if we know our y-intercept, we can just go that many units on the other side of the axis of symmetry and give us a symmetrical point. Okay, so that'll give us 5 points. So we're going to plot our vertex. Maybe it could be 1 point. Will be 1 point. Our intercepts could be anywhere from 2 to 3, and then also our symmetrical point to the y-intercept will give us a 5th point. Okay, an example of that would look like, so we're going to know our center is going to be 1, -2. Okay, and then if we want to next find our x-intercepts, so since there's no number here, a is 1, so we can actually say that this opens up. Our x-intercepts, we're going to plug all that equal to 0. So I'm going to add 2 to both sides. And now here's where we do our square root property. Since we have just a squared binomial on the right side and 2 on the left side, we're going to take the square root of both sides. This will be -1, and don't forget it's plus or minus. And then we are going to add 1 to both sides. So we're going to have 1 plus or minus the square root of 2 equals x. So that's going to give us our x-intercepts. Okay, and we may need to plug in a calculator in order to get that. And then the last piece is going to be our y-intercept, which means we are taking 0 and plugging it in for x. So we're going to have 0 minus 1 squared minus 2. Okay, and if we simplify that, That's going to give us a negative 1 squared is going to be a positive 1, minus 2 is going to give us a negative 1. Okay, so we have a y-intercept at 0, negative 1. And then we'll talk about how we get that symmetrical point in 1 second. Okay, so first part I'm going to graph my center, 1, negative 2. So I put my center right there. My y-intercept will probably be the next easiest point, 0, negative 1 is going to be right here. Now my x-intercepts are going to be, about just after 2 and just after negative 1. If you plug those into your calculator, you'll see that it's about negative 1.4 and about positive 2.4. Okay, and then the other thing I'm actually going to do is my axis of symmetry. Okay, and to do that, I'm going to go right through. Whoa, that's not what I want to do. I want a line. Here we go. Axis of symmetry right through my vertex being a vertical line. So how we get that other symmetrical point is you'll see your y-intercept is one value to the left, 1 unit to the left. So I'm going to put one unit to the right. Okay, and then the last piece, so if I have all 5 of those points, I can just draw my parabola. And a nice smooth curve as we can. Remember, we don't want a V down here, it needs to curve through the bottom. Okay, one more example. Again, we know this opens up. Okay, our center will be at 3, positive 2. Our x-intercepts means that I'm going to say 0 equals x minus 3 squared plus 2, and if I solve that, I subtract 2 from both sides, and here's where this one can get tricky. Okay, if we try to square root both sides, we're going to be taking the square root of a negative number. So we can't do that. So there are actually no x-intercepts, meaning the whole graph is going to be above the x-axis. So the last thing we need to do here then is find our y-intercept, which that one should exist. And we're going to say, so f of 0 equals 0 minus 3 squared plus 2. So 0 minus 3 is going to give us negative 3. Negative 3 squared is going to give us 9. Plus 2 is going to give us 11. So my y-intercept is going to be at 0, 11. Okay, so if I plot all of my points, I'm going to start with my vertex at 3, 2. And then I know I have a y-intercept at 0, 11. So I'm actually going to put a point way up here. And then before I do that, I'm going to draw my axis of symmetry right through the vertex, which means that if I am 3 units to the left of the axis of symmetry, I need to be 1, 2, 3 units to the right. And now I can, draw a smooth continuous curve there. Hopefully yours looks a little better than mine this time. Alright, so 3 things when we are graphing our quadratics. We need to find our center, our x-intercept, our y-intercept, and then we can even say the 4th thing is that point of symmetry using our axis of symmetry. Let's see, then on a half sheet of paper, you're going to turn to the beginning, is to write the equation if we know the vertex is negative 3, 4, and the graph passes through 1, 4. So see if you can do that before we start, or before you come to class tomorrow. For that, remember, you're going to need to say f of x equals a, and then x minus h squared plus k. So think about where you could plug some of the other values. Another way to think of this is instead of f of x, maybe if you say y equals a minus h squared plus k. Okay, that might actually help you out a little bit there. Alright, so that is it for this lesson. We graphed quadratics. We had standard form, which told us our vertex, and we could use it to find our y-intercept, x-intercepts, and a tells us whether we open up or down. See you next time.